Now let me ask Ana to come to the stage. And Ana is a psychologist. She is a doctor in neuroscience, and she works in an INSERM lab, the Imaging Institute, with Monica Zilbovicius, that the people at ARAPI know well. We saw her beginnings at this Université d'Automne. Ana will tell us about the interindividual variability of social behavior in ASD. And let me add that Ana is a member of the ARAPI. She is a member of the scientific committee. Thank you very much. Thank you, Bernadette. I would like to thank ARAPI for giving me space and for the space given to the research that we conduct under the direction of Monica Zilbovicius, as Bernadette said, in my institute, the Imagine Institute. I am now used to presentations rather. For those who have already attended the presentation, some things may be redux because you know, we do not reinvent research every morning. Everything that we do is within a continuity. Things start and then they build up. Monica usually says if we manage to add one slide per year in our research, that would make us really happy. So what I would like to tell you is how we have reached our stage today. We are very interested in this interindividual variability in social behavior, both in neurotypical and neurodivergent autistic development. There is a large diversity in the manifestations with people with extreme deficiencies, with very low IQ, nonverbal, and what they will have in common always is the social interaction disorders. And when you speak about social interaction, the importance of gaze is major. Gaze, that is really the entry entry into an interaction with the other. And which will be the base of the building of social competences, social skills. So gaze will operate in all the in all shapes. In the middle, my son, when he saw his little sister come home after the maternity, after birth, positive interactions. So gaze has a fundamental role, and in evolutionary terms, we can say that any social behavior, everything that we do and our positioning vis-a-vis others, first requires the recognition of our peers, what they are trying to tell us, the information that they're trying to transmit. And in evolutionary terms, there has been a major change between non-primates and primate mammals. Communication used to be in the non-primates through odor, smells, but in evolutionary terms, the recognition started through recognition of faces and voices, that is visual and auditory. So it's a major shift, a paradigm that requires changes in biological shapes in the brain to sustain and support these emerging capacities. Maybe you have already seen this short video. It shows the power, the strength and robustness of this behavior. It's a newborn monkey. Look at how it interacts with the examiner. And so even in terms of the interspecies interaction, you could see that the exchange based on gaze really has a major impact or space. I will not teach you that gaze in autism is very, very impaired. From the very early discussions by Kanner, it was observed. Things have not changed with all the DSMs and with the diagnostic tools. Anomalies and difficulties of interaction through gaze, through the eye contact, is something that will be observed as a constant. So I have lots of videos because my voice is a bit challenged. So twins, very young twins, and you will see how things work. The little boy will have a diagnosis of autism later in life. The little boy is in blue. Thanks, Sophie. And you see that the little girl, you see that she tries to get an eye contact with her brother as if she was calling out the interaction. And the little brother does not establish the eye contact. It doesn't catch. It's an atypical behavior that is disturbed early on in life, and you can imagine the consequence in terms of the cascade of social acquisitions that this would have, and that will be disrupted in the case of this little boy. This is so. For 10 years now, so for 15 years, I used to say, but now I must say for 20 years, we have eye tracking methods that enable us to investigate and measure this behavior, the gaze, objectively, because all the persons who have been around autistic children and have this experience of an anomaly of the eye contact. But the second thing is to have quantitative data. If you have quantity data, you can do analysis and correlations and longitudinal monitoring. With eye tracking has become even more simple. You can track the person's gaze or eye direction. And recently, you can look at the screen, but now even more recently, when interacting with a person. Amy Klein, who is really a pioneer in this area and who keeps working with eye tracking. Let me show you some minor examples how this method was used and everything that... So this video seen by a 15-month-old child and by a 19-month-old child with a typical development. So typical development for both. So this is not new. You know that the eye automatically, spontaneously, in typical development will focus on the face and the eyes especially. Whereas in a 15-month-old child with autism, you see that the pattern is really different. It does not go toward the eyes. It looks a little bit at the mouth, but mostly the information that are non-social details in the surrounding. So ever since I've come in the lab, 15 years now, we have investigated this new research area. And we were thinking that this is an extremely rich source of information, quantitative in terms of quality and quantity, on this behavior that is really affected in autism. but which is so important in the social skill development. So we developed our short paradigm in eye tracking, and we wanted them to be as ecological as possible, that is adapted to be used at any age with children and with adults, and that requires spontaneous and automatic processes so that we could study the essence of this behavior. So this is the base of the work. So this is scenes from the film Le Petit Nicolas. The scene as watched by a child with typical development. A typical pattern looking at the eyes, looking at faces, and from those information, the child will get the socially relevant, important information for the child to understand what is happening here, so that that child will, in a real life situation, get a proper position. And the second is seen by a child with autism. So we see a gaze pattern that is really impaired or altered, and this was largely described the anomalies of social perception in autism, with a missing preferences, not looking at faces, and the gaze going toward everything non-social. And when you do statistical analysis and you compare the groups of children with autism and without autism, children and adults. I tend to say children because I work more with children, but this is also something that you can see with children who do not have yet a diagnosis. So anomalies of social perceptions in autism, when you look at the eye going to look at the eyes, or the gaze toward the eyes. So now let's concentrate on what is there in this group comparison. When you compare groups, we have a set of data from one group and a set of data from another group, and we do an average with statistical thresholds that will tell us if we have a significant difference or non-significant. But you don't necessarily understand what is taking place within each group. And this is what it will be relevant for us, because we can present and represent groups. You have the histograms representing the standard deviations. That gives you an idea of the distribution. So it's not the same data. It's just for illustration purposes, where you have the boxes and the distribution of data that enables us to see that even within the same group, you have major variability, that people are not the same and measures are not homogeneous. Even if, when comparing groups, you find differences. So often the question is, can we go beyond group comparisons and go deeper in the group to investigate further what is taking place in individual behaviors? Again, in this universal attempt to try and get information on individuals or groups of individuals, to better understand the mechanisms and also propose something that is adapted. We started a first study on adults, and let me show you a video. It goes fast. And let's see how it works. I will show you images, and I want to tell you what you think looking at them. What do you see? My dad's car. My dad's boat. My dad's plane. It's It's really cute. If you haven't seen Le Petit Nicolas, please go watch it. So this is a short video that we show to people who work with us in the lab, grown-ups, children, typical, neurodivergent. If you come to my lab and if you get eye tracking, we could have observed that, for instance, one person would have, for instance, looked at this, like this, my dad's yacht, my dad's plane. So that's a recording of a person watching the scene. And the second person looking at my dad's yacht, my dad's plane. So it's a little bit different. It's not the complete opposite. It's not a pathological pattern. It's not pathological at all, but it's still different. So there is this notion of interindividual variability. Up to where can we measure this, and what can it tell us about social behavior? So we had a first study with typical adults. We had 14 volunteers who were watching scenes from the movie Le Petit Nicolas, and we were measuring the parameter, which is of interest to us, the gaze toward the eyes of the characters. And what we were able to see was that when we study the behavior of people in, again, typical development, we have a huge intervariability in this behavior. Again, pathology aside, we are going to have people who look at the eyes a lot and people who do not. This is in itself, in and of itself, it's not extraordinary. It's part of daily life. This is why some people will interact in a different way. But this type of approach gives you quantity and quality data. And we also checked that when you show the video several times in a row, you could expect them to have looked at something and look at something else and have a different pattern. But this is absolutely not what we see. What we have found is that people have a very characteristic and individual way of interacting, and this is stable over time, and it's a kind of signature of the social perception which is specific to each subject or each individual. And on top of that, the interesting thing is that the distribution of this behavior, as we can observe it, follows a normal distribution, like most biological parameters, size, weight, etc., as if this was an extra biological parameter. The question we had after that was, so if we have some kind of individual signature in terms of behavior, do we have brain correlates? So in the brain, is there something characteristic and typical of each person that could be associated with this behavior, which is very individual? And for that, in this study with grown-ups, we had MRI measurements. So they all had an MRI scan, and we had a measure of the brain flow, blood flow at rest, and we had a correlation study. A correlation study is a study that for each MRI image, we give a value. In our case, it was the number of gaze toward the eye region. And we ask our software, is there a region of the brain where the brain blood flow, because this is the parameter we study, where that flow varies depending on the gaze toward the behavior of the gaze toward the eyes region, when the gaze toward the eye increases or decreases? And the answer is yes. There's a region in the brain where the persons that look more at the eye will have a at-rest blood flow, brain blood flow. So the temporal superior region which is a very, very important region for the processing of social information. So beyond being very important for the processing of social information, that brain region is also modulated, or it does modulate the level, quote unquote, the score of social perception in the framework of typical development. As I said, we have people who don't look much, and the others who look a lot. And people who look a lot will have a higher blood flow in that region, and the opposite, and always in this region, not elsewhere in the brain. So, as I said, this is what leads us to talk about this notion of signature. Behavioral signature. We have patterns of social behavior that will be individual and typical for each person, and these signatures are associated to a brain signature that is associated and which is supported by this or that performance, quote unquote, in terms of social behavior. So this notion of signature is not new, and this has been used in eye tracking. Again, Amy Klein's team, or Amy Klein. So let me show you again a video not related to biological signature. So the green crosses is where the children were looking at, and you have a dizygotic twin recording, twins watching this scene. So the sound didn't work, but that's not important. So you see that these two persons watching this video are looking where there is this notion of variability between individuals. And then same scene watched by monozygotic twins. It's impressive. We are not in the framework of pathology. It's just in the framework of the individual characteristic with a biological base, as I showed in the brain, and this in genetic. This behavior of accessing information, social information, is related to a signature, to an individual characteristic, genetic, at the genetic level. So this is really interesting. And as I showed you the study we carried out with grown-ups. And now let me show you the results, more recent results that we obtained from studies performed with children. So the question was, maybe the grown-ups developed ways of being based on their experience, and do these phenomena that we describe of individual variability, does it also exist in children? So we did the same thing. We conducted the study in 4 children of typical development to whom we showed the same videos of Le Petit Nicolas movie. And what we observed was that we have exactly the same results, a variability between the individuals of this social behavior that follows the normal distribution in typically developing children who really focus their gaze a lot on the eyes, and the children who don't really look at that too much without being pathological. And now the question is, children with the autism, we have this notion of spectrum that is a large variability of symptoms and skills and difficulties. And is this something reflected in the social behavior? And the answer is yes. We have the same distribution that is in a group of children with autism. Even if you compare the groups and we say he looks less and he is impacted or she is impacted, we still have a large variability between the individuals with autism, the children with autism. Some children will look very little, and some who will focus a lot. And when we try to compare these two curves, we will see the difference with an average reduction of this phenomenon. But curves, I have not overlapped them. But these will overlap if you put them on top of each other. So again, we go back to this notion of spectrum, not autism spectrum, but maybe a notion of spectrum of normality, quote unquote, a spectrum of normal operation. So again, we are working on the brain. So we want to investigate whether we can observe correlations that will enable us to better understand what is happening, what are the mechanisms that can support or scaffold this or that behavior. And we looked at not the blood flow at rest, but a measurement of what we call the DTI, a diffusion MRI that will observe or study the microstructure of the white matter. So gray matter is the neurons, and the white matter is the connection between neurons. And how are we going to measure the integrity of the microstructure of the white matter? We measure what we call the isotropy of the water movement. Water, if the milieu is homogeneous, the water will diffuse in all directions, and that's isotropic. But if the milieu is constrained or restricted, when you have fibers, for instance, myelin fibers, water will diffuse in the direction of these fibers, and we call that anisotropic. That is a constrained diffusion in the direction of the fibers. So we have an FA map, and it's the measurement that we study when we study the diffusion MRI and connectivity, that is the white matter in the brain. And again, we had a correlation study where we asked the same question to our softwares and asking, is there a region? Are there regions in the brain where white matter, the integrity of the white material, white matter is associated with the number of eye fixation with typically developing children? What we observed was there is a correlation in these regions that you see in blue, where the children who look most at the eye will have a more important FA, that is an index of the fibers that is more structured, quote unquote again, okay? It's not the best expression of this, but there are more fibers and better anatomical connectivity in children who look more in the eyes compared to children whose gaze is less focused on the eyes. So these regions will connect, so the temporal and frontal regions. With children of autism, the interesting thing is that we observe the same type of phenomenon, the correlation with the integrity of fibers in these regions. Not exactly the same with typically developing children, but we are in the same networks. And this is important because whether in the typical development or it's a behavior that is scaffolded by the same brain network. And if I put both at the same time, you can see that it's close but not similar. And to identify what is dissimilar, we can do what we call an interaction analysis. And we ask the software to show us where in the brain the correlation is different between the two groups. There is a correlation in one group, but maybe not in another. And we observe that these are the results where you have in green regions where children with autism who look more in the eye region, that is those with a more adapted social behavior, have a more important anatomical connectivity, more fibers in these regions. And what this means is that the behaviors that we are describing in the spectrum of children with autism, when I say some children will look and more and others less, the children who focus more have more fibers in these additional regions, meaning that these correlations in these additional regions in the children with autism that were able to develop better social skills starts from a mechanism of brain plasticity that scaffolds the emergence and development of these better social skills. This is a bit different from, let's say, the results that we usually get and that we usually present, where we go seek anomalies and compare the group of patients, the control group, and then we describe anomalies to say in the brain of children with autism it doesn't really work properly, and there is problems, and there is a problem of neuron migration, connectivity, etc. It is very important to do that. It's important to identify dysfunctions. But I think that we also go toward another type of approach where beyond identifying dysfunctions, we also try to identify, as Pierre said earlier, the mechanisms for resilience and what is what can, at the brain level of the brain, help us better understand these mechanisms of resilience that help overcome the difficulties that are inherent to the disease, whether they are genetic cause or the dysfunctions at birth of the setup or the configuration of the central brain, and which can be overcome by mechanisms that we need to investigate and understand, and that will sustain or scaffold and sustain the emergence and development of new skills. This notion of resilience and compensatory mechanism is something that's new because, and I said that we are entering a new era, a new realm of research, and we try to understand in small homogeneous groups how things works and how different they are and how we can understand the differences. Who are these children? Who are the children for a reason so far unknown to us, with factors that are combined, probably biological, but also environmental factors of stimulation, management, care, and day-to-day work from caregivers. What is the starting point? Are these children who initially were less severe and are able to go further, or on the contrary, children who were less severe started from further and have a margin of improvement that was more important? What is the trajectory? Again, we always say that autism is a neurodevelopmental disorder, but if you think of it in terms of path or trajectory, what is the trajectory of these children who develop mechanisms of compensation that enable them to develop and harness social skills that are more adapted. And the others, why not? So that we can identify the groups that are more at risk or in difficulty, so that we can have a better action. So I was thinking about when preparing this press. You start with one question and you end up with 50, but that's good research, because when you start somewhere and you have other avenues opening, you have one question to which you try to find an answer, and then you find that there are 50 other questions that come. So this is what I wanted to present today. And I wanted to thank my colleagues at Necker. It's not something that you do in your corner on yourself, but this kind of research, well, for those who've done it, it's not easy to get a child with autism in an MRI machine. And it's a victory each time we do that for the family, for our team, for the child. Doing research on autism in France is not something easy. I don't know about other countries, but in France, it's we've lost public finances years ago. But I find that in our lab, what we do is interesting, and we have sponsors, foundations, associations that support our work. And I want here to thank families and the persons concerned who are real partners in this process. They trust our work, and we have a project that requires us to contact families that we saw 10 years ago, and they're really happy to continue with us. Thank you for your attention.